Now that we know how to use the quadratic formula, we've shown that it works when our quadratic is already factorable. But now, what happens if we can't factor our quadratic? That means that our answers are probably going to be irrational or imaginary. So I've got 3 examples up here on the board. I'm going to go through these and we're going to see that the quadratic formula works the same way. It's just going to be at the very end when we're going to see the irrational and imaginaries pop in. So let's dive in. So this first one, we know it's not factorable because 3 times 11 is 33. There are no factors of 33 that are going to equal 6. So we're just going to jump right into that quadratic formula. So n equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm going to simplify. My square root of, or my 6 squared is 36. Negative 4 times 3 is negative 12 times negative 11 is a positive 132 all over 6. So negative 6 plus or minus the square root of 168 over 6. So what I'm looking at here is 168 is not a perfect square. So when I square root that, I'm not going to end up with an integer, I'm going to end up with an irrational number. So we're just going to simplify our radicals like we've seen before. The factors of 168 are 4 and 42, and I square root both of those. The square root of 4 is 2, and 42, we can factor that to 2 and 21. Square root both. And 21 factors to 3 and 7. So here we're not seeing any repeats. So we're just going to multiply them back together and we're going to use the square root of 42. So negative 6 plus or minus 2 root 42 over 6. Those are my solutions, but I'm actually able to simplify those, so I'm going to do that. So 6, 2, and 6, they're all divisible by 2, so this is going to give me negative 3 plus or minus the square root of 42 over 3. We're still seeing 2 solutions here. We get negative 3 plus the square root of 42 over 3, and we get negative 3 minus the square root of 42 over 3. Okay? So it's the same process until we get to simplifying our radical. 168 isn't a perfect square, so our answers are irrational. All right? Our second example here. Again, not factorable, so I'm going to jump into the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So I'm going to get 2 plus or minus the square root of 4 minus 20 over 10. So that's going to give me 2 plus or minus the square root of negative 16 over 10. So again, quadratic formula is working the same way, but now I'm taking the square root of a negative number. Taking the square root of a negative number, that's where our imaginary numbers come into play. So we can split this to negative 1 times 16. The square root of negative 1, that's our I, and the square root of 16 is 4. So the square root of negative 16 is going to be 4i. So now I have 2 plus or minus 4i over 10. I'm going to reduce this because 2, 4, and 10 are all divisible by 2. So I'm going to get 1 plus or minus 2i over 5. And we still see our 2 answers. 1 plus 2i over 5 and 1 minus 2i over 5. Okay? 2 solutions because it's a quadratic, and they're imaginary because we took the square root of a negative. So we're going to just combine those ideas for our third example. You could go ahead and hit pause right now if you wanted to. Try this one on your own. Come back and check to see how you did. All right, so x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative 2 plus or minus the square root of 4 minus 56 all over 14. So negative 2 plus or minus the square root of negative 52 over 14. So our radical right now, we're taking the square root of a negative and a non-perfect square. So our answer is going to have a radical in it, and it's going to be imaginary. So let's take a look. I'm going to split my radical into negative 1 and 52. The square root of the negative 1 is my I. 52, if I split that, it is 4 and 13. Square root of 4 is 2, and I'm left with a square root of 13. So I'm going to replace my radical with 2i root 13 over 14. I'm going to simplify that, and I'm going to get negative, 2, 2, and 14 are divisible by 2, so I'm going to get negative 1 plus or minus I root 13 over 7. We have the two answers, negative 1 plus I root 13 and negative 1 minus. Okay, good luck.